For nearly a century, the Big Bang theory has been the cornerstone of modern cosmology. According to this elegant model, the universe began as a singularity, a point of infinite density, and has been expanding ever since. It explains the cosmic microwave background, the abundance of light elements, and the large-scale structure of the cosmos. But now, with the James Webb Space Telescope uncovering massive, mature galaxies that formed just a few hundred million years after this supposed beginning, scientists are asking a bold question. What if the Big Bang story is incomplete, or even wrong? The early galaxies Webb has revealed don't behave like newly formed structures. They're organized, luminous, and impossibly old-looking. That doesn't fit the chaotic, turbulent beginnings that standard cosmology predicts. So what's going on? Let's start by revisiting what the Big Bang actually is, and what it isn't. Contrary to popular belief, the Big Bang wasn't an explosion in space. It was an expansion of space itself. There was no outside into which it exploded, because space and time themselves were born in that moment. But this raises a fundamental issue. If time itself started at the Big Bang, how can galaxies exist that seem older than time? Some scientists are now exploring alternative cosmologies, radical new models that challenge the standard narrative and attempt to explain the anomalies JWST is revealing. One such idea is the Big Bounce model. Instead of a singular beginning, this theory proposes that the universe is cyclic. It contracts, collapses, and then bounces back into a new expansion. In this scenario, the current universe may have inherited structure or even matter from a previous cosmic cycle. That could explain how some galaxies seem more evolved than they should be. Another proposal is the emergent universe model, which suggests that the universe existed in a static state for an infinite amount of time before undergoing rapid expansion. In this version, galaxies or galaxy seeds might have begun forming long before what we call the Big Bang, giving them a massive head start. There's also the variable speed of light hypothesis, which posits that in the very early universe, the speed of light was much faster than it is now. This would allow light, and therefore information and energy, to travel farther and faster, enabling structures like galaxies to form more quickly than standard models allow. Then there's the idea of quantum gravity pre-Big Bang models, like loop quantum cosmology. These suggest that what we perceive as the beginning may just be a transition point, a bounce from a previous universe governed by quantum gravitational rules. In such a universe, time doesn't truly begin. It merely turns a corner. But perhaps the most mind-bending notion of all is that our entire cosmological model is based on flawed assumptions about time and causality. What if time itself is not linear? What if the arrow of time is an emergent property, one that behaves differently under extreme conditions? In this view, the early universe may not have been bound by the same cause-effect logic that governs our daily experience. Structures like galaxies could arise spontaneously, not through gradual formation, but through quantum processes that defy classical thinking. And then there are multiverse models, which propose that our universe is just one of many, a bubble in a frothing cosmic sea. If true, the conditions in our universe might not be typical. We may have formed in a rare pocket of space-time where galaxies assembled faster, earlier, and more efficiently than the average universe. Webb could simply be revealing that we live in a special, statistical outlier. Of course, these ideas remain speculative. They push the limits of both observation and mathematics. But that's precisely where breakthroughs often lie, in the space between what we know and what we dare to imagine. The early galaxies discovered by JWST are not just outliers. They are provocations. They challenge the Big Bang not by refuting it, but by demanding its evolution. Science thrives on such tension. It is in the friction between theory and observation that progress is born. At Infinity Beyond, we're not afraid to question the big ideas. We embrace the unknown, not as a void to fear, but as an invitation to explore. In our next segment, we'll explore one of the most controversial ideas in modern astrophysics. Are we misinterpreting the data entirely? Could the galaxies we're seeing be distorted by gravitational lensing, quantum mirages, or even observational bias? Or are they truly what they seem? Echoes from a time that shouldn't exist. Join us as we continue to unravel the greatest mystery of all. Where and how did it all begin?